All right, here we go again. So we're back looking at the wonderful Linux kernel. So here's where I left off at, just looking around at the file system. So file system code. Um, Here just looking around, looking at various aspects or information that's being traversed around here. Well, essentially what the file system code does. Pretty much just looking around at that. So we're in the X4 format of files, and we're looking at a file called ACL. So we probably need some sort of a, oh, we got a make file in here. Okay. Need some sort of README or something like that to understand what ACL means. Because when I see ACL, I'm thinking access control list. All right, but that's probably not the case. So here we have some sort of makes file to gather up all of the object files. So make file that makes sense. Make file makes sense. Um, yeah. So it looks like here though, the ACL file is this one says convert from file system to in-memory representation. Okay, cool. So that's what this does, right? So yeah, not sure um exactly what that means, but that sounds kind of interesting. All right. So then convert from in-memory representation to file system representation. So I mean, I don't know. What is this? Is this like swap space type stuff? I don't know. So the swap space type code, because going swap space is like virtual memory, right? So um yeah, so that's an interesting block of code, I suppose, right? Then we have inode operations. As we know, inodes describe pretty much resources within the Linux environment. All right, so that's it. That is an interesting structure to actually take a look at. I would think it's rather large. Let's see. Hmm. Yeah, couple of lines there. So that is a rather large little beastie. Yeah. So that's an inode, eh? Huh. Yeah, the inode is an interesting little beastie. All right, so it says kept mostly read-only and often accessed fields at the beginning of the struct. Okay, cool. I'm curious. I wonder why this wouldn't actually be made into a type using type diff, but yeah, don't know. That's interesting though. Probably depends on when the code was actually made or written. We don't have any comments that would give us that kind of insight in here. So it's interesting. So some of the comments have sort of dates that allude to, or I should say, at least a year that alludes to when it was kind of created and whatnot. So some files don't. So that's it's good to know. But yeah, inodes give us all kinds of information about, if you run the command of df-i, you'll get a list and insight into, inodes that are available and being used and all that kind of stuff. So pretty important because you can't do nothing if you run out of inodes in Linux. All right, so um, so there's a bunch of stuff going on up in here related to inodes. Is inode flags. We got a bunch of enums here. Suppose this is some sort of enum based on bits. So we're doing some shifting right here, some shifting of bits. Okay. All right, so we're bit shifting here. Yeah, bit shifting to make some enums. So these are various flags, I suppose. So inode state flags. Ah, so here we're getting state information that actually tell us what the state is for the inode. Hmm. You have a don't cache, dirty. So this is interesting. New sync, dirty, and lots of dirty. Yeah. Let's see, will free. It's that clear, referenced, linkable, dirty time. There's a lot of dirty stuff going on here. I feel a little dirty. Hmm. Okay. What else we got here? We got inode struct. In the inode struct, we got a umode, whatever the hell that is. What the hell is this? No, that didn't give us a definition. Let's see if we can actually go and find it. Okay, we gotta go through this to actually figure out what that is. This is some sort of function where it's being used at. Okay, well, let's go around here. I don't know what that unit is, but anyway, so that's something, some sort of I mode. Op flag, I flag, yeah, lots of flags. Got a couple of if defined, not defined, okay. All right, so we're using some POSIX structures there, ACL structures, and we're back here. Inode operations, various structures here that are being used here. Hmm. All right, so we got some constants there. Now this is kind of interesting. So you got okay. So from here, I'm thinking this means that the value inside of the pointer itself cannot be changed because usually, if it's a constant pointer meaning the actual pointer to what it points to can't be changed. I believe we define it that way. All right, so something to that effect. So you can actually change the location that's being pointed to, but well, not in this particular case. Here the pointer itself would, once you assign it, that's pretty much it's supposed to be done deal there. All right, so all right, so you got a super block. I'm curious to know what a super block is. Now here we get to actually see this definition. Super block looks rather large as well. So we got lots of different structures all over the place. Structural information here. So a super block has some sort of head, list head. Okay, so got a lot of struts going on throughout this. That makes the code, somewhat readable, I guess. These things are structured in various ways to give things context, give things some sort of context and semblance of, navigation and navigating through the code. Um, hmm, hmm, we're at the super types. Super types dot H. That is interesting. We have super types. All right, okay. All right, super block. Define and the super types. Who the hell, man? Super types, man. All right, I got a union here. Okay, well, whatever's clever. Let's keep on going. Let's see what else we got around here. There's flags, inodes. So I know where to come to some sort of inode crap. Some sort of inode crash out. Oh, it crashed out. Did inodes? Okay, cool. So where were we at now? Where were we at? We're back into our ACL. Okay, so we're in ACL. All right. So what else we got in here? So we got Switch statement. Doing nothing that interesting. Let's see what value is this. Probably some constant defined somewhere. Let's see if we go to a place that actually has comments and some sort of insights. Let's see. Okay, this is about 2016-ish. Who knows? Something like that. I guess that's the latest date you see here. And we got a bunch of, um, yeah, got a bunch of these defined all over the place. And, okay, got a bunch of constants, undefined constants. All right, a lot of preprocessor goodness. Huh? Okay, so not really much in terms of comments here. All right, type. Let's see, type field. So you positive entries. Okay, well, so got some stuff here. Okay. Okay. What about? All right. So this is pretty much only used if this is not defined, and we'll define all these thingamabobers. Okay, cool. So we have an if not defined here. Okay, cool. All right, so what else we got? We're just perusing around. I was curious actually about this right here, this error pointer here. I wasn't able to actually get to a uh, yeah, so it's like trying to search around and find it. I was trying to see if I can actually get to the location of this guy where this is defined at, because this seems like it might be kind of interesting, but oh well, okay. I guess not. That's what happened last time to me as well. All right, let's go to some other piece of the code, some other part of the Linux world's code. So bitmap. Okay, so we got a bitmap. Be nice to know what exactly. Okay, well, I guess not too much information here. It's back in 1995. Okay, I guess somewhere in Paris. Okay, so this code was developed somewhere in Paris. That is interesting. Right. All right, so let's see what the French can do. What do the French do here? Let's see, you got, what the hell is this? So this is doing some sort of count free, right? So you got a bitmap, you got a char pointer to a char. This is performing some kind of operation. Here we got, so number of chars multiplied by bits per byte. Bits per byte is 8. Surprise, surprise. So 8 times 1 char, assuming subtracting this here, whatever the hell this is. We don't know what the hell we got in there. Oh, so we got using a void pointer, which must be converted into some kind of other type. Okay. There we go. So there's no actual explicit, conversion. We're just assigning that void pointer to an unsigned char pointer. All right. So I guess the value inside of this bit would actually remain constant, or I should say inside the bitmap will remain constant. But is that the case? This constant sign, something, but so now I have to, because regular thing that makes sense. Okay, cool. So we're not actually changing the goodness on the inside. We're just actually traversing around. Here we're referencing the goodies on the inside, and here we're traversing around. All right, cool. So this is the number of bytes, right? We got this dude here performing. Well, this is kind of interesting. You got the number of bytes greater than 0. Fine. Assume maybe bytes is, I don't know, 1 byte or something like that. 8 bits, 1 byte. So yeah, we're performing this modulo. Okay. All right. So converting that to a long. size of long, such and such. Okay, I see, I see, I see. We're just trying to make sure that that is greater than, okay, I see. And then we're just gonna hit the bytes up, reduce the number of bytes, go to the next position inside of the bitmap, reference whatever is in there, add this up to that guy right there. So H weight 8. Okay. What the hell is this dude? This is some sort of a. Yeah, I could see these pound defines. Oh man, I guess you can keep on drilling down for quite a bit. I'm curious as to what generic interface. Right, that's nice. What does that look like though? What does it look like on the inside? Let's open it up. Split it open and let's see. Come on. Come on. Come on, take us to see. Go master. Okay, now, all right, so nothing there. Just was curious as to what that would be. So we got const underscore h. Wait, okay, so some sort of macro doing something with built-ins. I don't know what the hell that is, man. So, let's see what in the hell. Curious. All right, let's see what we got. We're gonna use this wonderful, the magic of Google. All right, so built-in is a compiler-specific built-in function primarily provided by as a part of CLang. It is used to determine if an expression value is known to be a constant at compile time. Oh, okay. Right, so we got a built-in to determine whether or not this is constant. Right, and then we have the tertiary thing with over here. So if this is true, get you. If not, do thee. Ah, okay. And these are for various architectures. Okay. We got an inline function definition for y. So this is probably so bit operations. Now that is interesting. Yeah, you got a whole lot of interesting bit operation. Hmm. Yeah. I know they just introduced in C23. I believe there's a standard bits. Let's see. Hold up. Let's take a look at that. Let's see here. All right. C23 standard bits.h. Right. I think there's something like that that exists here. Right. Okay. Okay. Yeah. So it was just introduced. All right, performing all these wonderful, providing support for a bunch of bit operations. That's cool. Um, so I'm curious if any of that can be used to replace this. And I wonder what version, I guess before C89, like what compiler standard could we actually use C23 to compile this thing, compile the kernel? I wonder. Well, I'm gonna give it a shot. Don't know what the hell's gonna happen there, but yeah. That's pretty interesting to check out the bit operations. There's a whole slew of bit operations going on in here. All right. So you wonder, you got these items, again, as just a little review thing, it's just a code readability thing. Like, why wouldn't you just, slap that into a pound define statement, right? So, ah, I guess the assumption, if not that and not this. Oh, okay. So we're performing a bit operation on that right there, and I'm gonna shift that on over. Boop boop boop, and then okay, perform some operation on that. Whatever the hell is going on here? Okay. Define such and such and such. Interesting little pieces of stuff. Oh. So really, ideally here, the question is, what? A lot of little interesting pieces of code to learn from to actually do other things as I'll be doing. Right now, this is boring. The boring, I would say, boring investigative work. Perusing around, mini heap. So min heap. Hmm. Uh, okay, min heap. What else we got? What the hell does min heap do? So we got a bunch of inline operations performing heap stuff. Not really seeing too much. Let's see. Too much detail into function definitions in min heap. So I guess I need to scroll down a bit more. Okay, where we at? Where we at? Okay, so we're just okay. So everything is defined. Function definition is actually defined in the .h file rather than, well, I mean, it doesn't, as same kind of deal, because all we know, essentially we know that the pound include literally just includes the file inside of the other file, right? So it's all, and I didn't even know, you don't even, it doesn't even have to be called .h, like a header file. You can name it whatever the hell you want. That's an interesting C little tidbit. All right. So, okay. So we're including the header, and inside of the header, we're actually defining the body of all of these various functions here, and that all in line. Okay, cool. All right. What else we got? Once. So we have a file called once.c. What does that mean? This thing runs once? Once deferred. Hey, if you defer me once, you bet not defer me again. Ah, man, once disabled, jump. Whoa, okay. Don't jump on me, man. All right, so anyway, so what was it? So we got strut once work. Oh, okay, it's right here. We got once work, we got work strut. Okay, what the hell is a work strut? Has some atomic data up in there. Has a list head. Strut. I wonder if this is a actual type. Okay, so it's a type. They perform the type def. Okay, cool. Right. So they're using that strut. They did a type def. That's interesting. You're doing a type def on a type def, right? So you define the strut. And I just wonder, we have all these an ocean of struts. Why aren't all the struts just, type def? Some are, some not. Right. So right here we got some are, some are not. This guy right here, got a strut, some are, some are not. Okay, well, guess it depends how often the strut's being used. Right? So just being used internally only or externally as well as a type all over the place. So okay. I mean, if it's used in more than one place, it makes sense to make it a type, right? Just reduce the amount of code and all that kind of stuff. Yada yada. Okay. Hmm. But if you're only using it within a particular context, then I suppose, one location, one place. All right. If once work only, is only used in this particular file and nowhere else, then that makes sense. I'm just curious though. Let's see. I mean, it is a .c file, but that doesn't mean that it's not used all over the world, huh? Yeah, let's just see. Let's do one of those right there. Let's see. Let's let it go ahead and peruse around. All right, so yeah, so that's pretty much. I forgot to turn on a little music. Music helps. Helps to go ahead and what we got on this thing here? Uh, let's see. We got all kinds of stuff here. We got a bunch of goodies, I suppose. Hmm. I haven't heard these guys for a minute. Oh yeah. Kind of goes with the mask, no? Yeah. Oh man. All right. So yeah, it's probably not used anywhere else. Plus, there's a ton of files that we'd have to go through. Oh, another bug. Dang. Oh man, bugs. All right. So yeah, let's let that do whatever it's doing. We'll probably come back to it at some point. Check that out. Spin lock. Are we using any locking mechanisms like semaphore and all that kind of jazz? Static define lock. Okay. Export this symbol. Export this view right here. Okay. You know, I was wondering if you have some sort of actual locking mechanism, what's the context of this? Spin lock, huh? We got signal.h. Yeah, signals. That's interesting. So, okay. Spin lock. So we're just sort of navigating around. I'm looking up inside of here. I'm thinking we're locking. We're doing some kind of something, right? Okay, so we got a pound of, okay. Now this is interesting. I definitely didn't know or think of, yeah, man, that's cool. Okay. Well, I didn't know you could actually do that. I didn't know that you can actually type a function sort of in line like that and actually perform a while on it. So I learned something new. And then what is, oh, okay, I'm going to experiment with this right here because it's kind of like looking at this, like, what's the point, right? So you look at this thing, you're going down, you're just doing a wild do, you're going down literally just one time, and if this is zero, so you're literally just going through this code like one time. So that's interesting. Couldn't do that another way. All right, sort of like, okay. Ah, really curious as to why you would actually do it that way. Yeah, it's been long. So okay. So let's take a look. Let's see what. Huh. Yeah, let's take a look at that. This right here, this mechanism or this setup, it doesn't quite make sense to me that you actually have while loops that are being executed like that just for going through this code, one time. I don't know what's the deal. Is it that you can't have a block? You know what I mean? You have to sort of make this fictitious block to actually execute two statements here. I check. Okay. It is interesting. I'm gonna have to actually peel this out. Peel this turkey out. Let's go ahead and let's go ahead and let's make a new file here. Call this turkey notes. I'm gonna look at this, right? I'm gonna do some investigation into this particular statement because I didn't know. Yeah, it's curious as to why you would do something like that, and I didn't even know that was possible. So maybe that might be something useful and interesting there. I'm curious to know what the performance impact of something like that. Like literally, could I? Yeah, yeah, I don't know. I don't know. Because essentially you're doing a define, and usually that just replaces everything. So you're just totally creating this function block. Yeah, that's interesting. So all right, anyway, I'll experiment with that, and then probably have another video on various kinds of experiments performed with some of the coding techniques that I've learned by looking through the kernel. That's pretty much the whole purpose of this exercise, at least for me, is to go through the whole kernel and look at, observe code and fool around with it and whatnot, and eventually get to the point where, as I said, I'm going to sit down and literally touch every line of code in this bastard. So you got a parser. Wow. Wow, man. Isn't that like dangerous, man? You know what I'm saying? You telling me that now I get it, there's conditions in here that allow you to break out or return and all that kind of stuff, but I'm just like, I don't know, man. I just feel a while one just makes me feel itchy. You know what I'm saying? That makes me, especially in like kernel code, I start getting itchy and nervous. Oh, dang. All right. So, but yeah, I mean, I get it. You definitely, the expectation is that you're going to have some kind of break or return or something like that. Some statement that's going to break it. And I was just like, dang, that just made me, yeah. Anyway, so, okay, so we got a bunch of pointers being passed in an array. Huh. So then you got to wonder to yourself, okay, so you got an array of these guys right here, which is a bunch of two pointers from and to. Describe the location within a string, all right, in a string of a substring. Okay, cool. So this is, two locations. Okay. How is that being used? Hmm. So you got a bunch of sub information. So basically metadata, I guess, for um various parts of a string, and that's parts of that string, I suppose, right? So from there, from there to there. Okay, in this particular length, and you just sort of go into this part of the string right here. So this is, I guess the beginning of the string to the end of that substring or whatever it is. So it's just going through different parts of the string. But the thing I'm trying to understand, then, wouldn't you be changing changing this? Oh, okay, I see. So we're actually performing this operation here on that. Okay, okay, okay. So this makes sense. So right here, so we have our, okay, yeah. Performing a comparison there. Okay. All right. I'm just trying to see. So, okay. Trying to see what else is performed. Okay, here we go. So this is where we're actually performing some movement, because otherwise that wouldn't make sense. So you're actually moving around right here, moving Mr. Pointer around, and then we're going to various locations, and we're going. Okay, so now that makes sense. Because here now you're pointing to a different part of this string and doing what you're doing. Okay, cool. Okay, we're doing some parsing here. We got some sort of token. All right. So you're just using that match one. Okay. Mm. Okay. All right. Okay. So we got some specific stuff that we're actually doing here. So we even have some comments here. So that's kind of cool. Determine if a string matches a simple pattern. All right. All right. Okay. I guess that's our pattern right there, and then here we go. So the real max. Okay, so that's cool. So okay, so yeah, that's interesting. That's cool. So we got some kind of parsing goodness going on in here. Scan around, match. Okay, yada rada rada. So we got different versions of our match function here. Calling number and whatnot. Ski. Okay, cool. All right, so you got some parsing goodness going on here, and we're still inside of Hmm. Where are we at, man? Where the hell are we? Hey, that's why it's just so easy to just get to fool around inside of these things here. Okay, okay. And once it's a parse. Okay. We were in the file system code base, but now I have went to a lib. Hmm. All right, so all right, cool, cool. There's the file system here. We were in here. Okay, so continuing to peruse around. I'm tired of file system stuff. Let's what? Bad inode. Hmm. So these names are just like, yeah, it makes you like pause for a little bit and say, what the hell is going on there? Symbolic link info stuff going on here. So what? Huh? I mean, so this is just, hmm, right. So, now this is kind of interesting in that it's weird. We have bad bad inode literally just not doing anything, right? We have a bunch of parameters here, and we're just passing these things in, and we're just not doing anything with them, and we're just returning values. I don't know. I don't know what's going on here. This is strange. So here we're defining a strut, initializing one of the values inside of this particular strut here. Um, yeah. So this is, yeah, it's curious stuff. I don't know. So these are a bunch of static functions, and you're returning an it, all over the place here. We're not really doing anything. So I don't know what really what's going on in here, and we don't have much of comments. It says okay, it says all file operations assigned to EIO. Well, this is back in 2003-ish. I guess maybe they just took this out of commission, and that's how you oh yeah, that's how you deprecate things, I guess. I don't know. Subtle way of deprecating various functions. Just passing back an error code saying whatever error code 5 means. It means something, we don't know. We just know that these are error codes, and this is, I guess, error IO, some sort of input, output, or IO kind of issue. Error. All right. Microsoft based stuff here. Okay. Yeah, I don't know. So that's curious. There you got another buffer. Some sort of other buffer definition here. Remember we had a buffer definition inside of the context of the accessibility console. So here we got another kind of buffer. Let's see how this is. So we have a head, buffer head. Does it have a body? Yeah, so that's curious to know. Let's see if it has. Well, yeah, check that out. So we got a pointer to it. So a circular list of pages buffer. Okay. All right. Let's see. Is it? Okay. I'm just curious to see if it actually had an associated body. Apparently not. A bunch of allocation stuff going on. Yada rada rada. Okay. Nothing. Inline definitions. So we got put H. Okay. All right. So some kind of buffer. A lot of dirty. There's a lot of dirty. I love that word dirty. Dirty. All right. Cool. What else do we have going on inside of here? So we got some sort of buffer definition, event, probably some sort of file descriptor. FD. That's what I'm thinking when I see FD. I'm thinking, all right, something to do with file descriptors and signals, it so seems here, right? system call through signal. All right. All right, all right, all right. So, so we got some sort of signal thingamabob going on here. Event with file description. So, all right, let's get some context. So we do have some actual comments in here. Every time a write is performed on an event, we have an event strut. Okay, some sort of strut here. Alright, let's see. The value of such and such being written is added to the count and a wake up is performed on this. Okay, so alright, so this is interesting. So you got some sort of wait queue. So inside of this wait queue, find something here. You got some sort of spin lock action going on here. So there's some sort of wake up thing going on. Alright, let's see what is that. Okay. Alright. Well, I wasn't expecting just a one field strut for spin lock, but simplicity goes a long way, huh? So I guess extern, these things are defined somewhere else, and used all over the world, I suppose. Okay. 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 Yeah. Alright, so let's see what was this? List head. Okay. Well, that's interesting here. Okay, I'm going to check. I mean, I get what's going on. This is an interesting way to probably structure some data structures. So standard. Oh yeah, you trying to kind of wonder what do we got? Where's my little file at? My notes. There you go. So there's some notes here. All right, cool. So what else do we got? Well, I think that's good enough for right now. So there's some cool little stuff going on inside of callback. This struct is aligned with the size point of almost all architectures haven't actually used any architectural lines. Guarantee. This guarantee is important for a few reasons. Future will make use of low pointer instructions such as the storage space. Okay. Page tail. So we got a bunch of function pointers over here. Alright. Alright, I think it's time to call it a good quits here for right now. So just found some interesting code in this, event. I'm assuming file descriptor. Should be function descriptor too. We don't know, right? Increment the event counter pointer something function support the call of kernel. Do not allow speaking function pointer. Okay. See what it's actually doing. So we got a bunch of flags in here. So we have this right here, perform some sort of lock operation, spin, some sort of spin lock. Deadlock or stack overflow issues can happen if you recurse here. You wake up handlers. I guess these wake up handlers are like callbacks or something. Well, maybe not necessarily, but some sort of handler. Okay. See, a caller potentially nest. Okay. So here, going through a function list, not answering such and such. Oh, so we just actually saw that structure. The list header, so we're just going to the next position. Oh, we're just checking to see whether or not these are the same. Read once. What the hell does read once look like? Compile time, assert once type. Read once. Instead of read once, if you do not require any atomic Note that this may result in tears. Oh, damn. Well, we're going to end on that note. Note that this may end result in tears, man. We see a lot of interesting comments inside the Linux code base. Anyway, guys, that's pretty much it for right now. Probably gonna, yeah, continue from where we left off and continue looking around for interesting code. That's pretty much what I'm doing. Just looking through the Linux kernel here, looking for interesting code, and finding some and taking notes. And that's pretty much it. All right, man. See you guys later. Peace.